Thanks so much, everyone, for coming. Welcome to PyData. This is actually my first time here, so it's a completely new experience for me. I'm going to be talking about pandas today. How many people in here have heard of it? Okay. How many of you have used it? All right, then this might be, you guys might teach me something at some point. How many of you have heard of SQL too and like use that? A lot of you. Okay. So my background is I learned databases very early on, like when I started working with computers, but I never really had like a true data structures and algorithms course. So I used SQL a ton, and I thought in these kind of like tabular structures. And when I was first learning pandas about 2 years ago, there was no good way of kind of approaching pandas from a SQL perspective, because that's what I knew, and that's kind of the viewpoint I wanted to approach things with. So I wrote a long blog post, which has now morphed into this talk. Give me a tabular structure. Don't give me like weird nested JSON data structures, because they can be goofy to work with. So the goal of my talk today is to give everyone a foundation for pandas. Definitely going to take like a wide and shallow approach. And I think it's kind of good that this is one of the first talks of the conference, because I'm sure a lot of other talks will kind of talk about pandas. So it'll be a good reference point. I want to emphasize that this is a tutorial, actually, and not a talk. So I'll be talking a ton, but if people have questions throughout, feel free to interject, and I will be happy to continue that conversation. I'm actually not sure why I wrote and back either, because if you can translate something one way, you can kind of translate it the other. So I'm Greg. If that cartoon looks familiar, that means you've probably wound up on my blog for some reason. Or you've been ordering Grubhub, which is actually where I used to work. So like I mentioned, my background isn't a true computer science or engineering. I actually studied economics in college. So I think in terms of like data analysis and all that. And so my background, I led the data team at Grubhub for 3 years. And I recently joined a company called Datascope Analytics, where I'm a data scientist. Datascope, this is my one Datascope spiel slide. We kind of work at this weird intersection between like data science, design, and strategy consulting. We take a human-centered approach to data science. So step one is always making sure we're actually working on the right problem. And we use a ton of Python. Pandas. So it started in 2008 by Wes McKinney is when development started. He was actually working at a hedge fund or at an investment firm here in New York, and actually convinced them to open source it. So good job, investment firm. What his goal was with the project was to make Python great for data analysis. At the time, if you think about it, like a lot of people were using SQL, using R, using Python. Python, now we kind of have this one language that we can be productive in quickly if we want to do data things. And what it actually is I like to think of it as a nice human-centered wrapper around NumPy. So NumPy can be a little bit tough to work with at times and a little bit unintuitive. Pandas makes NumPy really nice. There's a huge active community too, which is really awesome. It's actually led by Jeff Reback now. Wes his company was acquired by Cloudera, so he's working for them. But Jeff Reback is actually speaking here tomorrow at 1:30, I think, and he's going to be talking about new features that have been in the most recent release of Pandas. But the community is awesome. I've actually contributed to Pandas. There are 300 contributors, and I had never contributed to open source before, so Pandas is really nice in the sense that on the documentation pages, there's a whole section that's just, here's how you contribute to Pandas. So it gives you the process, how to work with the contributors. It's a lot of fun, super easy. And that book is actually a book Wes wrote about 2 years ago that covers Pandas in depth. I'd highly recommend it if any of you leave here today and kind of want to know more about Pandas. So I searched for a data janitor, and this is kind of what came up. I thought it was a funny picture. I think the cool thing about it too is that our janitor actually looked like he just came from a graduation. But so this is the problem that the pandas set out to solve. Data's kind of crappy. It's never just right. It's like a Goldilocks problem. You're always trying to like munge something into like this nice little perfect form where all of your data types are clean. You're not mixing strings with integers or whatever. But something's always mildly off. And the old workflow, at least for me, about 2 years ago was, all of my data was in a database. Grubhub's a web app. So we were on top of MySQL. So I'd be writing SQL, tons of it, rolling data up as necessary. Then I'd pull it into Python, and I'd kind of like munge it a little bit more. And then eventually I'd pull it into R to do some sort of modeling or data visualization, because R had ggplot, and ggplot was awesome. But there's a high cognitive cost to that. Like, I'm not kidding when I actually say I found myself writing SQL or Python in my R studio. So that can kind of get confusing. So Pandas solves this problem. It allows you to stay productive in the one language and to kind of work throughout your flow without a high cognitive cost, without that switching cost that you had before. And one of the big things about Pandas is that it lets you focus on exploring. So we kind of have, all my slides just dropped. So we kind of have all of these like Pandas astronaut explorers that want to answer questions about space, and Pandas lets you get into to answering questions. And so it has that low switching cost. And I think that's one of the great things about SQL, especially if you have data in the database. SQL is great at allowing you to answer questions quickly. It's super high level. It's very intuitive. Oftentimes, it's like you're speaking English, right? It's like, take these tables, show me these things from it where this condition isn't true. Python was lacking that. And the issue I had with R, and I think a lot of people had with it, is that R could be a little bit too forgiving at times. The syntax is kind of weird, but at the same time, you'd read data in or you'd do some sort of transformation on that data, thinking it'll run, and you thought what you just did was correct, but in reality, you realize 10 steps down the line that something was off about it. And the nice thing about Python, and Pandas in particular, so Pandas is very expressive, it's very easy to read and understand, and Python's whole motto of there's only one way to do it, it removes that problem of silent errors. If it's going to fail very loudly, and it's going to fail early. So meaning you're not going to get 10 steps through your analysis and realize my whole transformation was just off. So another thing about Pandas is that it's kind of a PyData glue language. Data frames, which is one of the main structures of Pandas. Data frames work very nicely with things like scikit-learn, stats models, Seaborn, matplotlib. It's very easy to kind of just take it and call a plot method, and all of a sudden you now have this nice plot. The other good thing about Pandas is that it kind of connects to any sort of data source you can imagine. So you can hook into a SQL database, flat files, Excel, you name it, it's in there. It's a great PyData foundation. The one thing Pandas isn't is it's not a database, actually. So Wes gave a talk here last year, and this was one of the things that he emphasized a lot, is that it's not a database, it's not tightly coupled with the database. I think the quote he used was, it's too far away from the metal. And the problem with that is that Pandas is great for in-memory analytics, but when you're working on these massive data sets, at times you can't suck a 100 million record file into memory. You can, but your computer is probably going to grind to a halt pretty quickly. And the thing about Pandas is that when you actually hook into a database, the database reader methods are a little bit memory intensive and can kind of slow you down. Some of the other things he said were that group bys and joins aren't what they could be in Pandas, and those are things that a database is made for. That's what SQL is great for. So one of the things that I hope to have you guys take away from today is that Pandas is great for a lot of things, but in some ways databases are pretty fantastic at doing these grouping, these joining operations, and if possible, in your analysis, you should push that sort of work onto the database and then bring it into Pandas. And that's the approach I tend to take in my work. Pandas isn't necessarily going to be able to compete with something like an Amazon Redshift right now. And if anyone doesn't know of Redshift, I'm happy to talk about it after the talk, but it's pretty amazing. So here's what we're going to cover today. We're going to cover data structures, series data frames. I'm going to talk about indexes briefly, but the main thing that I think I'm going to want you guys to take away is just that indexes aren't columns. They look like columns in data frames, but they're not. And if you try to treat them like a column, it's not going to work. But so we're going to go through selecting, joining, grouping, filtering, all that kind of stuff. And then I'm going to be trying to use SQL-like keywords throughout, but if I don't and need to clarify some things, feel free to speak up. Someone asked me, actually gave this talk at a meetup in Chicago on Thursday night, and someone asked me if I was going to cover pandas SQL in depth. So there's a library called pandas SQL that I think the guys at Yhat wrote that allows you to write SQL against your data frames. And while that's awesome, I'm not going to cover it only because the goal of the talk is to translate SQL to pandas, not write SQL in pandas, if that makes sense. There's also a ton of time series stuff in pandas. I'm going to talk a little bit about it, but if you tend to work with a lot of time series data, I would say explore the documentation a bit more because there is so much functionality there that you couldn't even cover it in an hour-long talk. And then at the end, I'm going to get into some applied analysis using IPython Notebook. I'm going to be working with the Divi data set, and what Divi is it's bike trip data, like rental bike data throughout Chicago. I think here you guys call it city bike. So the first data structure, it's the series, which is a one-dimensional kind of structure. It's a heterogeneous object, and it's kind of like a list. So if you can see in this top line, we're creating a series by passing it a list, actually. So 7, so an integer, a string, we're passing a float there, a large integer, and then another string. And we kind of get this object with our values in a column. So a series is actually very similar to a column in a database, or in R, it's called a vector. And if you notice along the left side, there's kind of that 0, 1, 2, 3, 4. That's our index. Because we didn't pass an index, an explicit index to the series constructor, we're seeing pandas automatically adds an auto increment integer for us as the index. If you actually look below, though, so we're passing a dictionary now, and we're passing Chicago, like various cities as the keys, and then arbitrary numbers as the values of those cities. And because the series constructor knows how to take a dictionary and use the keys as the index, once you pass it to the constructor, we now have this nice list where our indexes are actually kind of metadata about the series. It makes for nice data alignment and to kind of keep a little bit more information about your records. Does that make sense to everyone? Cool. So series slicing, like getting objects out of a series, it's very similar to getting objects out of a list in the sense that you can actually just use standard Python slicing. So if you see in the top image, we're selecting the second and third records of the series. So much like Python slicing, it goes up to the last value. So we're only getting Chicago and New York here. But because we also passed in that nice index, and actually any index we pass into a series, or any index on a series, we can just take cities and then put square brackets around it and give it the index label, and it'll give us back that value. So if that index label was actually that auto increment, we would just pass in a 0 there and it'd still give us that value. You can also get values out of a series using Boolean slicing, and what Boolean slicing is within the square brackets, you pass in some sort of condition. So this is kind of like your where clause in SQL, and that condition actually filters down the series to the objects that you care about. So here we're saying, show me the cities where the value that they had was greater than 1,000, and we only get New York and San Francisco here. And lastly, we could actually do Boolean slicing. Series themselves have a lot of methods. So in the case, if you actually remember back when we created this series, you can see Boston has none. So in pandas, that's going to be, it's called NaN. In NumPy, I think it's NaN. In SQL, it's essentially your null value. So in pandas, you actually can just say cities where the cities is null, and that's why we get Boston. So you could actually do some basic operations on series too. So if you see in that first record, we're actually changing the values of the series. So we're saying, show me all the cities where the value is less than 1,000 and change it to 750. And then if we look at the series, we can see that Austin and Portland were the two that were less than 1,000, and they now have this 750 value. You can apply arbitrary math upon series. So here we're saying, take every every item after the third value in the series and add 7 to it. So now you can see New York, Portland, San Francisco have all had some basic math done to them. The last one can be a little bit weird and can throw you for a loop at times. I know it has for me. So when you're mathing a series, if you're mathing two series together, what ends up happening is that they join on the index. So if there are index values that are not shared between the two series, the operation that you just tried to perform will return a null object. So if you can see in that last example, the only item that's actually, since we're slicing the city series, the only city that's actually shared between the two is Chicago. So all of the other cities, because when you get a none, because when you add none to a value, it returns none, right? So the absence of a value can never create another value. Make sense? Okay, cool. Data frames. So that's one of the other main structure that Pandas introduces. And a data frame, you can think of it as an R data frame, or you can actually also think of it as a table in a database. So you can create it many ways. Here, I'm just passing a list of dictionaries to the data frame constructor. And I'm actually specifying my columns and the ordering I want my columns in. So actually, if I wouldn't have passed that columns parameter, my columns would have been ordered alphabetically. And so in regards to that parameter, that's another big thing about Pandas is that every method and every kind of function that's in there has a wealth of parameters that I invite everyone to explore. We'll talk a lot about them, especially when you get into the reader methods. Pandas the developers have thought through a ton of different ways and a ton of different issues that you might run into when reading data into the library. So back to the data frame though. So here's kind of just this arbitrary way you call a list of dictionaries, and all of a sudden you now have this nice tabular structure. Obviously, a lot of times you're going to be reading data in from various files or databases or maybe even APIs. But I found that this constructor is really a nice way to kind of get moving on a data frame, just because often I'm scraping, I don't know, NBA data or baseball data or something like that. And I usually have my methods return a list of dictionaries like this. So it's nice to, when I want to get into my analysis, just pass that method to the data frame constructor and get going on it. Another big thing, too, about data frames is that you can actually think of them as a group of series that share an access, or a group of series that share an index, I'm sorry. And data frames actually have two indexes, or indices. Along the top, you have the columns, obviously, but that's an index. And that's actually also called an axis in some parts. So it's a data frame is a two-index, two-access object. And the top index is access 0, and the one along the side is access 1. So main thing to just take away there, that column headers are an index of themselves, because you can kind of just tilt a data frame arbitrarily. Does that make sense? Okay, cool. I'll explain it a bit later. So yeah, like I mentioned, I gave this talk on Friday, or I'm sorry, on Thursday actually in Chicago. They were kind of my guinea pigs. And I had a lot of stuff on this slide about indexes, but ultimately I decided to delete it all and just say they're not columns, because that's all you should take away from right now. You can think of an index like a primary key column, but the weird thing is that with a primary key in a database, you can just select it normally, right? Like you could say where this condition is met on the primary key. You could join on primary keys, all this kind of stuff. In Pandas, if you want to select from using the index values, there are different methods now. And if you want to join using index values, you have to specify different parameters of the join functions. So the main thing to take away is that, at least for me when I was first learning Pandas, indexes were probably my biggest source of confusion. So just take away that they're not columns, and if you run into an error because you're trying to do something on an index, there's probably a different method that you should actually be using. Or you can just change the index, which we'll talk about too. The main goal of indexes are to maintain the structure of the data frame, provide metadata. So like we saw in that cities example, we're providing some information about the other objects. And for data alignment, so you can actually look at your data frame in a nice structured way. So demo time now. So now we're going to move to the IPython notebook. I think some of you might have just come in recently. So if you want, I have an IPython. The notebook is on my GitHub if you guys want to clone it. It's just GJReda and then / PyData 2014 NYC. And it seems like some of you are going to do that, so I'm going to wait a little bit. Or if you guys want to fire up IPython notebook. I think all of you are using the Anaconda install, or maybe. I'm not super familiar with how to load this via Anaconda install, or like how to start the Anaconda environment. But so what you could actually, what you do from the command line to fire up IPython notebook is just type IPython notebook in the directory that you want to launch it in, and it'll kind of load up all the files necessarily. So if we were to do this here, it brings us to the page. Let me go to demo.
What's your handle?
GJREDA. I probably should have made like a bit.ly link or something so that was a bit easier, but. I think the Wi-Fi network here is WeWork. If anyone has having problems with that, there's an open network. Are people still getting it? OK, I'm going to get into the demo then. It seems like most people have it who want it. So is anyone here actually not familiar with IPython notebook? So everyone has used this before, like knows about it? OK, cool. Then I don't need to talk about it. So standard IPython notebook stuff, we're loading our libraries, and we're saying we want to use matplotlib inline. Can everyone see this OK too, actually, for the most part? Yeah. Hang on, I'm going to hide this header too. And we're actually going to. OK, so loading everything. So imagine we have a CSV file that we want to read into pandas. So pandas has a lot of different ways to read from files, and it can read from almost any type of file you can imagine. But here we're going to read in a basic CSV file. For you New Yorkers, we're going to read in Mariano Rivera's statistics over the course of his career. So in that repo you just downloaded, there's a directory called data, and there's a file called marianorivera.csv. You could just obviously pass a string of the file name to the read CSV method, and now all of a sudden we have this nice data frame structure. So I didn't run the top. So we have this nice data frame structure. And there are various methods that, like I mentioned, pandas, the developers have thought very, very, very deeply about reading your data in and any sort of problems that you could run into during that. So since most of you are familiar with the IPython notebook, you could actually just go in the function and type Shift-Tab, and all of a sudden you see the parameters that they've thought deeply about. So we can change the separator. Is there file compression? So maybe it's a zipped file. We can convert various objects on the fly as we're reading it in. Are thousands fields delimited with a comma? So the read CSV method, if you're running into issues, check out the parameters, because there's typically a lot of stuff in there that can already help you. You don't necessarily need to write crazy Unix commands to grep out fields or find and replace using sed, because most of it will be here for you already. So it's kind of just reading CSV into a data frame. But one of the nice things about pandas, too, is that you could actually just fetch from a URL. So if you look at this URL, it's pointing back to a different directory in my Git repository. So we'll go take a look at it, just so you guys can see. I'm in Chrome. So what this actually is a magazine in Chicago did an article that was the best sandwiches in Chicago, but every sandwich was on a different page. So I kind of got annoyed and just scraped it all and put it in a CSV. So you can just see it's a tab-separated file here. And it's a URL. We can go to pandas and actually just pass this URL to the read table method. And what it's going to do is pandas knows to go out and fetch that object, and it'll try to read it in. So here we're saying, here's the source of this information is actually the URL variable I gave you. It's separated by tabs. And then here's a little wonkiness at the top. We're actually using this converters parameter to convert the price on the fly. So if we look at the source data, there's actually, let me find one here, and then I'll highlight it. So right here, if we see this 950, there's a dollar value in it, and actually all of the decimal values, so 950, 750, whatever, have 2 periods. So it ends with a period, and then obviously we want to keep the one to separate the cents. When we're reading our data in, we don't want this to be read in as a string, because that's obviously, we're not going to treat it like it's a string. Maybe we want to sum it or take the average price, something like that. So we're going to convert it on the fly as we're reading it in. So here I'm writing an arbitrary function to find and replace all that excess stuff that we don't want. And I'm using a lambda function. Is anyone not familiar with lambda functions? OK, so we're getting a couple hands. So what a lambda function is in Python is it's just kind of like this function that you're able to throw away. Someone can probably explain it better than I can here. But so instead of going through the standard syntax, so that function is actually the same. We'll talk about this piece of the function. Sorry, the first section of it is actually the same as if we were to say declare a function called clean, and say we're going to return s.replace $, and this is, hang on. This is if there's no period. If there's a period in the price, or in S, we're going to turn this. And we're going to leave off the last value because we know that's where that extra period is. So otherwise, return. I actually don't need this else, but. So this lambda function here, it's kind of ugly. I probably should just split this up to make it clear. Is exactly the same as writing the function in this way. The lambda function is just kind of like, it's an anonymous function. You can use it once and then it's kind of there. But here we're actually storing a function in a variable because Python is kind of functions are first class objects there. So exactly the same. So what's actually happening is when we read this in, we're applying that lambda function. And I'm creating another one here because I want to convert the object to a float on the fly. So as pandas is reading this, we're cleaning up each instance of the price, and we're also converting it to a float at the same time. Does that make sense? OK, cool. And then here's kind of what our data looks like. And you can see the price is this nice field now where it's good decimal amounts. Pandas can also read from JSON. So here I'm actually hitting the GitHub API for some issues in the pandas repository. And you can just pass it. So we'll look at the JSON. It's not the right thing. And it's just this ugly JSON structure, and it's nested. But so what you could actually do is just say, hey, pandas, go get the JSON object at this URL, and then we'll read it into a data frame for us. So you can see here we're selecting just the body, the created at date, the title, and the URL from that data frame. And I'll get into this a little bit more when I talk about how you select from a data frame in a similar way to how you select from a SQL table. You might need to do some parsing, actually, though, when you read in from a data frame. And the reason using the read JSON method and the reason for that is that, like I mentioned, data frames can store any sort of, it's a heterogeneous object. So it can actually, a cell in a data frame can actually store another JSON object. And if you think about data frames are kind of like this relational structure a lot, almost like SQL, and JSON isn't relational, it's nested, so you might need to parse out additional things from a column. Does that make sense? OK, cool. This is actually probably one of my favorite things about pandas is there's this read clipboard method. A a lot of times I might be writing SQL and then I just want my data in a data frame very quickly. So we'll actually use this raw data again. So if I just highlight it and Control C, and I go back to the demo and hit Control, now we have the data in the data frame again. So it's a really quick and easy way to get your data into a data frame. A lot of times, I use various like SQL editors, and I'll have my data right there in a nice tabular structure, and instead of going to read it in, I'll just copy it to the clipboard and then read it in. But you can actually also hook into a SQL database just fine. So here we're using SQLite, and you can actually just create a connection, and all you have to do is pass the connection to this read SQL this read SQL function, and then give it the query, and you'll have your data into a nice data frame here. And here's another example where we're kind of converting things on the fly. Knowing that the data in the SQLite database isn't a nice, it's text. The date is text. It's not actually a nice date time. We can convert it on the fly as we're reading it in. So we're saying, take the date column, and here's actually the structure of the date. Here's what it looks like, and this is using standard Python date conversion parameters. Does that make sense? Yes? Okay. So I'm going to read this in because we're actually going to be using this a bit more now. Yes?
I lied when I said I used Python before. What are the keystrokes you're going to run the cells?
Oh, so Shift-Enter will run the cell and create a new and move to the new one right below it. Control-Enter will run the cell and just keep you in that current cell. Does that make sense? So I'm mostly using Shift-Enter. So here, I kind of talked about how you could just use the standard Python slicing to kind of inspect your data with a series. You can do the same thing on a data frame. So here we're actually looking at the 100th record to the 105th record, standard Python slicing type of stuff. But you can actually also use head and tail. And head will show you the first 5 records of the data frame. Tail will show you the last 5 by default. Okay. Another good practice that I always kind of have when I'm working with data frames is as soon as I read something in, I use this toad. I use the data frame, the .info method. And what .info does is it shows you a bunch of basic information about your data frame. So on the left side, you can see actually the columns. In the middle, you can see the number of columns that are not, the number of values in those columns that are not null, and then also the data type of those columns. So if we actually see, we kind of have a problem here in this data set because the model were empty strings. Pandas, we didn't convert on the fly to a null object. So pandas, an empty string is a value. So pandas thinks that those are actually values. So here you kind of need to look at these sorts of things to make sure you're catching everything. But if we actually look at the Mariano Rivera data set we had from earlier, we can see there's an instance here at the we used .info on it. We can see that there's an instance here at the bottom where there were 4 years in the data set where he didn't win some sort of award. Make sense? Okay. The other nice thing too about inspecting your data is there's a describe method, and what describe does is for any numeric field, it's actually going to give you various basic statistics about that numeric field. So you could see, there were the wins column was populated, the wins field was populated 19 times, and he averaged 4.3 wins over the course of his career with standard deviation of 2.08 and a percentile range of 3 to 6. Make sense? The one thing you have to be wary of when using this describe method is, like I said, it works on any integer field or any numeric field. So if you've read in a user ID, obviously statistics about a user ID are kind of irrelevant. So back to indexes, and let's illustrate how they're not columns. So here with that Toad data set, we're going to set the index to date, and we're setting it in place. And it's something I want to point out is that a lot of Pandas methods will return a copy of the data frame. It won't actually modify the data frame. So you either have to use this in place parameter, which is available on most methods, or catch it in some way. So if we weren't going to, sorry, this just jumped me all the way to the top here. If we weren't going to do this in place, we would have to delete this and then catch it in like a random object here. But we'll modify it. So now, if we actually look at our data frame, if you remember, we had that random auto increment index. If we look at it here, you can see the date is now this index along the left side. This changes the way now that we have to interact with that date. So now if we want to say, let's say, we want to see all the towed vehicles that were towed on November 4th of this year. If we run this, we use this IX method, and we use square brackets. If it were a column, we wouldn't actually be doing this, and I'll get into that later. So here, .ix, I'm actually going to remove this because I didn't put limit 5 here. So that's actually what we're doing. You can see here the various vehicles that were towed on November 4th of this year. So again, that's when you have an index, you can use this .ix method. And if we actually wanted to see an individual column while using that ix method, we can pass that same November 4th or whatever sort of index selection we want to select, and then call that specific column name. So here, we're selecting the make column for all the vehicles that were towed on November 4th. And what actually happens is we get a series back. So this is a nice series object if we were actually to do type. And like I mentioned, a data frame is a group of series. You can actually see that this is actually a series here. Now going back, now let's say we want to select the same vehicles that were towed on November 4th of this year, and that column is no longer an index. So here we're going to reset the index. So we're going to get back to that auto increment. And we're going to do it in place. And so now, hang on, I'll move this up here to make this more clear. So let's run this. Now, if we be towed head, see, we're back to that old index, right? So crummy index doesn't necessarily mean anything, and our date's just a column again. Now, again, yes?
When you index on date, does the date column go away and it becomes an index?
Yes.
And then when you did this thing, it came back?
Yes. Yeah. And I'll show something. It can be confusing. That's why indexes are not columns. So, we're selecting. Let's say we want to see vehicles where the date's November 4th, 2014. We get to this point again where we can't use that .ix method anymore. We have to say, we have to use Boolean slicing again. So what this is doing actually here is saying, this is making a series of true-false values where the date is November 4th, 2014, and then it's passing those true values to the data frame to only return those objects to you. So to make that more clear, I'll show this up at the top. So this is how, using the square brackets, is how you can select a column from a data frame. And we're applying a condition here now. So we're saying, show me, let's do a comparison of the various values of the date column to this standard string date. And what we get back, false, 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 false. Let me make this. So there's a method here called value counts to show you guys that some of these are actually true. See, there's 70 of them that are actually true. Okay? So here, all you're doing is you're passing that list of true, false values to the data frame, and it's selecting the ones where it's true. And so, again, now that it's not an index anymore, we have to treat it differently. Okay? Does that make sense? Yes?
So does it use the ordering of the index?
Yeah, by default, yes.
But does it use the ordering of the index from the series or from the data frame when you do this?
Oh, for how it sorts?
Yes.
It's going to use it from the data frame.
So if the series is out of order, it will still keep the ordering in the data frame?
Okay, sorry, now I know what you're asking. The series and the data frame are going to be the same order because you're selecting a column from...
But if it came from some other source and we're of a different order, it will keep the data frame order, right?
Let's talk about that after, but it can be confusing. Okay, so moving on, we can go to... So now like I mentioned, when you make selections, if you want to see various columns, you can actually just, hang on, I'm going to set this date index back. So you can actually set various columns that you just want to see. And all you actually do there is you pass a list of the column names to the data frame, right? So here we're making a list and we just want to see the make, color, and the state. And we pass that list to the towed vehicles data set. Make sense? Okay. So here we're just seeing the first 5. And now back to the filtering, like I mentioned, you can pass this series object of true, false values to do your filtering. So here we're going to say, show me all the towed vehicles where the make is Ford, and then we're actually going to sort it by state. So we're applying now a little bit more logic. We're getting a little bit more SQL about this, and do it in descending order. And I think in most of the cells, I've tried to put the equivalent SQL statement so you can kind of compare them back and forth. So here, selecting the ones that are Ford, and we're sorting it by the state. And since we're using the head method, we're saying show me the top 5. And since we've sorted in descending order, you can see that these are towed vehicles from Wisconsin. To do and or conditions now for filtering, what you actually end up having to do is you can use the ampersand character for an and. And when you're doing multiple conditions, you have to pass them in parentheses. So what actually ends up happening, so here I'll run this and we can see that it works properly. But if I were to actually take these parentheses out, we're going to get an error here because pandas doesn't know how to make the comparisons, and it's going to say it can't compare a scalar value. So right here, it can't compare a d-type Boolean array to a scalar type, right? Because what's actually happening is it's trying to compare, using since it's a string here, it doesn't, it's throwing it in. Does that make sense? So if we use an ampersand, that's an and condition. Now if we use a pipe, that's actually an or condition. So here we're saying, show me all the towed vehicles that were a Porsche or the state was New York. Given that this is Chicago data, there aren't many New York towed vehicles here. So you can see here we have some that are Porsche, but these other ones are actually in New York here. And then we're actually applying a little bit more logic here. So we're sorting again, but we want to sort by multiple columns. And when you want to do things with multiple columns, you're almost always going to pass a list of those columns. So here we're saying sort it by make and model, but then our ascending values is we actually want to sort, we want the make to stay sorted ascending, and we want the color to sort descending. And we'll actually see that the only one that we could actually see example of it is, I think this Porsche, hang on, I left a comment here because it's hard to find because there's only one, yeah. Not red Porsche, I believe. So if you could actually see, this red Porsche is actually sorted, red is the one that's appearing higher when in reality it shouldn't if we were to keep an ascending sort. Or a descending sort, yeah. And so what we're actually doing when we're passing these we can actually it's the same thing, we're creating those true false values. So we could actually create a filter mask. So we can say towed, where the style's a 4-door and the state's Illinois, and we're going to store it in M. So M is now actually just the series again, right? So say M value counts, and we see that there are about 2,600 where it's true. So now we can just pass that towed M, we can pass that condition, the filter mask, to the data frame, and we could actually say, well, actually only show me these columns too. So this will run for us, and we're selecting only a couple columns because we're passing that list of columns while also passing that filter mask to filter our data for us. And then we're also applying a sort and what's equivalent to a SQL limit. Does that make sense? Yeah?
Just go that one. Value counts.
Yeah, no, we're actually not passing the value counts. I'm only putting that there to illustrate that there are some that are true, because otherwise you might not be able to see them. So here, if you were actually just do M, it's that series of true false values again. Make sense? Okay. And so if anyone's ever worked with a crummy database where you've potentially had to find duplicates, it can be a real pain in the butt, right? Especially if primary keys aren't done. If the database hasn't been created in a very strict way and somehow duplicates got in there and your primary keys aren't really a unique object, you're grouping by tons of columns, you're getting counts and all that kind of stuff. Pandas has this really nice way where it kind of just murders SQL in that area. Toad has a duplicated method, so we could just say, show me all the Toad objects that are actually duplicated, and then pass those that true-false series again to the data frame, and we can see here's some vehicles actually where they're showing up twice in the data frame. Okay. So let's get to joining. The only reason, for those of you that might not be familiar with IPython Notebook all that much, you can actually execute arbitrary command line arguments here. So what I'm actually doing is I'm grepping for values where like a numeric field has a column in the middle of it. And the reason is that, so this is the Divi data now, the bike trips, if you go over 1,000, it starts turning into a string now in our file. So this is going to be a pain in the butt to read in. So I just wanted to illustrate that. So here's what our two files look like, and then weather data, which I actually don't end up using. But so now let's read in this Divi data, right? So we're going to create two new data frames. One's going to be trips, and one's going to be stations. And they match up, they join to each other on the station name. But before I do that, if we can see this date format, it's just a string. So we want to actually parse the date properly so we can work with that. So I'm going to create another Lambda function that I'm going to call toDate. And all I'm going to do is tell it how to parse the date. Okay? So we can read in the trips data, the CSV, and using this converters parameter, we can say, take the start time and apply this toDate function, and take the stop time and also apply this toDate function to it. And since, like I mentioned earlier, we know that numeric field, the thousands, have a comma in them, we can say thousands, it's got a string. There's a separator for thousands, that's a comma, so it'll parse that for us properly too. So let me run this cell so I actually have the method, and then this will run. It'll take a little bit to run. So pandas actually, if you notice at the top, earlier on when we were parsing dates, which file was it? It was with this Toad vehicles data set. We used the parse dates method. You can actually use that. You can actually just give that. I won't go find it again. The parse dates method, when you're reading data in, you can just give it true, and it'll try to parse every date. Yes?
So, have you ever seen a throw argument?
What's that?
So, I think it goes on to step 3, frame throw argument.
Okay. So if you actually, so you can give that parse dates argument just true, and it's going to try to parse all the dates for you. However, I'd advise you that if you're working with a large file, be explicit about parsing your dates. I actually found the other day that when you're not explicit, when you just give it true and it tries to figure out the date format for you, it ends up taking 6 or 7 times more to read the data in than it would if you were to just explicitly pass this data.
When you're parsing dates, does it try to apply just one method to each column? Like, so I have a data set at work right now.
Yeah.
Where I have dates entered in different formats.
Yeah.
On different rows within the same column.
Parse dates.
It'll handle it.
Parse dates will handle it. So the reason it's slower is because it's trying a whole bunch of different methods against it. So now that we've read our data in, we can just look at the data set, and we can see that using .info, we have 760,000 bike trips with various metrics, with various attributes about each trip. And you can see that our date time and that our date fields got parsed in properly, and everything else kind of looks good here. In the stations set, everything got written fine. There are 300 stations, and those are going to map. So the thing that we need to note here is that this from station name maps to the name of the station, and then the to station name also maps to the name of the station, because obviously each trip has an origin and a destination. How many of you are familiar, I think everyone here was familiar with SQL. Does everyone know joins, how joins work in a database? So basically I saw a couple everything about a join is really databases rely on kind of like working in sets and set theory, which is way out of topic here. But all you're doing is you're taking two objects and you're joining them together, and it's going to allow you to kind of like pull in various pieces of information about it all. So this is actually a really nice graphic. It's a Venn diagram showing you the various joins of a database and how actually they work in terms of sets. So here, now that we know we need to join the trips and the stations data, so let's imagine we wanted to create a map that is every trip that was taken. Well, that stations data has the latitude and longitude. The trips data doesn't. So we need to pull that latitude and longitude into the trips data set. So here we're going to join the trips using the merge function, and we're going to join it with stations, and here we're going to say the left join. The reason we're using how left is because we want to retain every trip. So imagine there's a scenario where some station was actually, there's a station that's not in the station's data set. We don't want that trip to fall out. We want to keep that trip. So we're saying, show me all the trips and match it up with the station. But if it doesn't match to a station, I still want to keep it anyways in the data set. And we're being explicit. We're saying left on, so the left data frame, we're saying join it on the from station name. And on the right, we're going to join it to the name. And then if we look, we're catching it in this divvy data set. And if we look, we actually now have our data set with these new columns, which were the stations columns pulled in. Let's join it again, because we actually have to join it twice, right? Because we need the latitude for the origin station, and we need the latitude for the destination station. So we're going to join it again here, and we're going to actually take the data frame that we just created, which we called divvy, and join it on the stations. And here we're going to say inner. It really doesn't matter which one I did here for the purposes of this, but it's just showing that if you want to do a left join, a right join, an inner join, or even a full join, in this how parameter, you just pass the type that you want to do. And here we're going to say left on the to station now, right on the name. And because we actually already have the similarly named columns on the data frame, we're going to pass in these suffixes. So we want to label that one of the latitudes is the origin, and then the other is the destination. If I didn't pass in the suffixes arguments here, pandas would have just named it _x and _y to allow us to differentiate. But you can actually be explicit about how you want to name it. So here, if we look down, now we have these repeated columns, but at least one set is called origin and the other set is called destination, or dest. Now, another thing about SQL, right, is sometimes you want to union tables together. Sometimes they're partitioned or something like that, and you just want to union it together. So here, I'm just showing how to do it. It's actually something I don't use too often in pandas. But here we're just creating two random data frames with a bunch of random values. We're going to call them df1 and df2. And if we could go look at one of them just to see what it's like. We could say there are 3 values, just arbitrary numbers. And all you actually have to use is this concat method, this concat function. So you pass the list of your data frames, and it will concatenate them on axis 0. Remember, so I talked about how the headers are actually an index, and they're often called axes in the parameters and the parameter arguments. So it's going to concat them on axis 0. So here we could say this full data frame now where A and B have kind of have joined together and created a new data frame. To illustrate kind of what happened, if we were to actually call this C and recreate this, and then now we'll see df2 is A and C. If we were to run this, we're going to see that it created a new column, and because B didn't have a match, it's just going to create a new column and shift them over, and everything that didn't match up is going to get nulls. Make sense? The nice thing about this concat method actually is because it takes a list of arguments, you can pass multiple data frames to it. So there have been situations where I've been scraping NBA data or something like that, and I have a series, I don't know, let's say 100 data frames. I can just make a list of those data frames and pass it to concat, and now I have one nice large object for me to work with.
Is that the same as append?
Yes, it does work the same as append. I think the arguments are a little bit different on them, but they kind of achieve the same things. So one of the weird things about pandas, and it was really a struggle for me to figure out at first, is that you don't loop in pandas. You can, but it's not really a great approach to it, and it can kind of be a little bit confusing at times. So what you're actually doing is you're vectorizing operations. Vectorization is kind of a little bit out of scope for this talk, but it allows you to kind of parallelize operations. Whereas looping, you're doing things sequentially and procedurally. If you vectorize it, you can apply it to a larger set in a quicker amount of time. So this is an example of how you vectorize things. It can be, I'm happy to talk a little bit more about it after. I just wanted to kind of get across the point that you're not going to loop. So in the Divi data set, the start time and the stop time are precise to the minute. What if we didn't actually want that? If we wanted to, let's say, round it to the nearest hour. So 9:05 gets rounded to 9 o'clock. So here, we're going to create this round time function. And all this is going to do is it's going to do a little bit of math and round our data to the nearest hour for us. And so, the old way of doing this, or not necessarily the old way, but the looping way of doing this was you'd iterate over every start time, you'd call this function, maybe you'd store it in a new list or actually modify it in place. Here, you're not going to loop, you're vectorizing the operation. So you're saying, take the start time series, or the column, right, because every column is a series, and apply this round time function to it. And what we're doing here is we're actually creating a new column that we're going to call start hour. And the same thing here, we're going to call another column called stop hour. Make sense? I'll show it just to kind of illustrate it. Divvies, I didn't run the top parts. Meh. Okay. So here we'll go back and we'll run this. And what we're actually going to end up seeing, I guess I didn't even really need to run it, but the start time here, so if we look at 12:11, it rounds to noon. 12:55 rounds to 1 o'clock. You can kind of see just, if we were to want to plot the data and it's precise to the minute, it can be very noisy and jittery and it would be a little bit too much for us to see at one time. So again, you don't really loop in pandas, you vectorize. You write a custom function and then you apply it to either the entire data frame or just to this series that you're actually cared about. And if you want to store it in a new value, you can just say it equals this new column, whatever you want to name that new column. So grouping in pandas. Pandas draws largely from Hadley Wickham's split apply combine paper. If any of you are or are not familiar with Hadley Wickham, he is an R developer. He's written a ton of packages for R. So if you've ever used R and worked with ggplot, plier, dplier, reshape, there's a whole bunch of them. He's written awesome stuff for R and made it a really great data munging language. And he wrote this paper called the Split Apply Combine Methodology for Data Analysis. And what it actually says, it's a great paper, you should read it. What it actually really says is it gives you an approach to thinking about a data analysis. And oftentimes, you want to break things down into smaller, manageable pieces, apply some sort of function to each of those pieces, and then just combine it back to one large frame. So while it's definitely, it's a little bit, it can be a technical paper because it talks about one of his libraries. At the same time, it's a great way to think about how to approach an analysis. And that's kind of what I've found is that the paper's just great for helping you think. So here's kind of what it looks like. So let's say we have this data frame or this series where we have some sort of key A, B, C, D, or A, B, C, and a bunch of numbers. We're going to split it apart on the key values, apply a sum function, and then combine it back together and get this smaller data frame that's actually it's rolled everything up for us, right? So it's similar to a group by. If you've ever done a pivot table, a group by, you've kind of worked in the split apply combine method without really thinking about it. It's fairly intuitive. So start trips by hour. So let's say we wanted to say, all right, we want to group our Divi data by that start hour that we created, and we want to see how many trips were taken in each of those start hours. So here, we're going to use the group by method against Divi, call the column we want, and then apply a size method, right? So this is just going to count the number of trips that were taken there, since our data frame is all the trips. So you can kind of see this, and what you actually get back here, and in this case, is a series, right? So if I were to run this, we see this, our series, and again, if we want to do a type, it's a series. So when you're using these group bys, oftentimes you're getting a series back. So that's now creating a new object that there are additional methods available to if you wanted. So like in this one, we could do value counts, actually, and see, actually, it's not going to work because the number of trips, actually, yeah, we can. Value counts. So we can see, okay, there are actually, there are 6 start hours, or sorry, there are 68 start hours, or there are actually, I got to think about this. There are 68 instances where there were 6 trips taken in that start hour. Okay, makes sense. But more so illustrating the point that you get a series back, and now you can kind of do a whole bunch of work on that series, actually, if you were to want to. So let's say we actually wanted to see the start hour with the longest mean trip duration. So here, we're going to group by the start hour again, and we're going to say we want to apply the mean function to just this one column, the trip duration column. And because we want to see the longest mean trip duration, we're going to order it in descending order, and then we're just going to look at the top 5, right? So here's what this would look like in SQL. We're grouping, applying it to the column, and then we're sorting. And we get, okay, so June 27th at 1 a.m., the mean trip duration was 31,000 seconds. I don't know what happened. Someone probably was just drunk and forgot to return their bike or something. But so, again, just showing a little bit more group by. Now, if we wanted to actually apply a function to multiple columns and also multiple functions to the same column, what we end up using is this ag function for aggregate. And we can pass a dictionary applying telling it which column and which functions to apply. So let's say we want to see, so there's a user type in the Divi data set, and you can subscribe or just be a customer, so anyone can go rent a bike, or you could actually have a year membership. So we're saying, let's say we want to see the unique number of birth years by user type, and then we want to actually take the mean and median trip duration by each user type as well. So here, passing this dictionary, we're saying birth year, use this series unique function, right? Because we want to see the unique number of birth years. And for trip duration, since we want the mean and the median, we pass it a list, right? So it's going to apply both of these functions to this trip duration field. And when we get back is this nice kind of structure showing us the information that we kind of wanted in return. Does that make sense? Okay, cool. And then this is kind of the last part I'm going to get into. One of the awesome things about pandas is that there's this nice plotting integration with matplotlib. Matplotlib can be a little bit frustrating to work with at times, especially if you need to do a lot of custom things. My view at this point would be if you're doing a lot of visualization, maybe look at something like Seaborn. If you're wanting to change the colors of your visualization and all that. But there's a great talk Rob Story gave at PyData in Silicon Valley. I think it was last year. And I think it was called Up and Down the Python Visualization Stack. And really, he goes through a whole group of visualization libraries for Python and kind of talks about which ones are good when. So I would recommend checking that out. In the demo notebook, I have a link to his slides in the video, actually. So here, we're going to group by the start hour, and we're just calling size. So this is that same series that we looked at in the first example, the number of trips by each start hour. And we can actually just call .plot on it. And here I'm just passing in the figure size because I want the visualizations to be big so you guys can see them. And so what we get back is just this pandas kind of knows how to plot this already for us. So we can see it's very noisy a little bit here. But in the week, during the middle of the weeks, we see that there's a little bit more noise because people aren't riding Divi bikes as much during the middle of the week. It tends to be a weekend thing, mainly because there are a lot more tourists in Chicago on the weekends. So now if we wanted to see the distribution of trip duration, we can actually just take the series. So Divi, now we're accessing that series trip duration, and we're getting a histogram. If we just plot the histogram, then we're going to bin it to 1,000 bins. We get this nice histogram, and we can see that it looks like some sort of a log normal distribution here. And there are a lot of rides that are super long. And actually, I limited the access a bit because this would have gone on and you wouldn't have been able to see this nice kind of curve that goes out in long tails. Now let's say we wanted to see the percentage of Divi rides that are less than 20 minutes or the percentage that are less than 20 minutes. So if you think about it, it's a cumulative distribution function here. So we want to see, of all the Divi rides, what percentage is less than 10 minutes. This can be a little bit goofy to do, so if anyone actually knows a better way to do this, I would love to talk to them after. So here we're going to take that trip duration, and we're going to get the value counts again, and we're going to store that series into a new object, which we're going to call duration counts. And then here, again, we're not treating an index as in a column. We want to name the index seconds, and we want to name the column, so that the values of that series, trips. So here's what the object's going to look like after we're done with it. We can see that the index is named seconds. And what the index actually is now, again, it's the number of seconds for that trip. So we can see that there are 712 trips where it's 408 seconds. Okay. I don't want to work with an index here because we need to kind of get a rolling sum of the percentage, right? Because we're getting the cumulative distribution. So we need to get a rolling sum of the percentage. So we need to reset the index and create a data frame. So let me run this so we can actually get this. And I'll show you guys what this looks like. So if it's df head, we can see, we have a data frame again now, right? So we've reset the index. We can see that there are seconds and trips. Yes?
You can do this one line. You go back to your previous example, the previous cell. Just say data frame.
Okay.
So we need a data frame, and then you pass the name and the column and index name. Just one line will give you that.
Cool. Thank you. So now we have our data frame. We want to create a new column called minutes. So we have to take the seconds column and we have to divide it by 60, right? So if we run this and we set it back to minutes, so now we're going to have this object data frame head, and it's going to give us the number. So we've set the index to minutes because when you plot with pandas, the index is going to plot along the x-axis. So we want to look at the distribution, so we need the minutes along the x-axis. So we have seconds and trips, and now what we end up doing is for every series, we can call a cumulative sum function. So this is going to give us the rolling sum. So up here, if we were to do, let's just show how this works. If we were to call the cumulative sum on trips, we can see it's a rolling sum of every object before it. And finally, when we get to the end, this should be the length of this series, right? So we apply this cumulative sum function, and then we apply the total number of trips in the data set, or we divide it by the total number of data sets in the trip to create a percentage, right? So up here, it's 68 divided by 760,000 to create the percentage. And then we can actually, I'm putting it in parentheses here, so this is actually creating a series, right? Because when you divide a series by a scalar or another series, you get a series back. Remember the thing back early on when we talked about how when you're mathing, you can just apply, you can add 7 to it, and you're just applying 7 to everything in the data frame. So here we're doing a little bit of math, and we're keeping the new series, and then we can just call plot on it, and we can see this nice cumulative distribution here that about 35% of the trips are less than 10 minutes long, and about 70% of the trips are 20 minutes long. There's a whole variety of different ways that you can actually use the plot method. There's this kind parameter that'll show you kind of differing plots. So here, let's say we wanted to see the number of trips taken by each birth year. And we're going to do it using a horizontal bar chart. So here we could say, there are a ton of people that were born in '85 that take trips. There were not so many people that were born in '70, and if we go all the way down, there are even some people that were like 1930. There's one person that was born in 1930 that's taken a trip. Here we're going back to lambda functions again, and I just want to show this. Actually, I'm going to skip this one because I'm going to use it again here later on. So here we want to see we want to start comparing men versus women. How do they take trips? So here we're using the supply function again, and because our start hour is a date time field, we're calling a lambda function and just extracting the date, and we're going to create a new field called start date. So again, here we're not looping, we're just vectorizing the operation by applying another function to it. And so we're going to group by start date and gender, call the size, and now we can see that this data frame we have an index of the start date, and there's this multi-level index, the secondary index here of the gender.
What's happening in that top line in 49?
Oh, so here I'm extracting the date. So this start hour field is a date time. I just want the date. So I'm creating a new start date field. Does that make sense? I'm happy to talk about it after.
Why do I writing div dot start hour and not div square bracket apostrophe start hour apostrophe square bracket?
Can we talk about it after? I think I'm running close to time actually here. So the last thing, so if you actually do this, we could actually see, since we're going to want to plot this by men and women, we're going to need 2 columns, one for men, one for women. So we can actually unstack the index. So what happens, let me run this so I could actually unstack it. But so what happens when you unstack it is, instead of having this multi-level index, we've now tilted that second level of the index and created columns out of it. So now, in SQL, if you were to do this, you're going to have to do this count if gender equals male, and then apply some logic, count if gender equals female, do some rolling, some aggregation. Here we could actually just say group by start date, gender, size, and since we know that the gender is the second level of the index, Python, it's zero-based numbers. So we could actually just say unstack that second level, which is 1 here, and then show us the first 5. So here now we have these 2 nice columns that are female and male. And then if we were to call plot on it, it's going to graph it nicely for us. So now we can see that a lot of the trips are taken by men, and there aren't so many trips that are taken by women. Similarly, we can do the same thing with subscribers, actually. And the plot method has, when you're doing a group by plot like this, there's this nice subplots that we can just pass through. So now we can see consumer and subscriber, and we actually get 2 nice plots here for us so that we can compare them, and they don't necessarily have to be on the same graph. And then lastly, we're going to do a little bit more stuff to kind of get into unstacking. So here we're going to we want to extract the day of the week from the start time. So we're creating weekdays, a series of weekdays, and then a series of hours. So again, we're just extracting the hour. We're going to group by the weekdays and the hours, and we want a count of the trips. So here we're naming it, and we're going to create a data frame out of it. So if we actually run this, we can see that I should have printed this data frame. We can see by weekday, weekday hour. We can see, so we get the weekday on the first level of the index, and then the hour on the second level of the index. We're going to unstack the first level because we want to kind of look at it by weekday. So if we actually, I'll show you with the unstack. 0. Gotta close my parentheses. So now we get this kind of matrix-like structure that has the weekday along the top, and 0, I think, in Python is Monday, and the hours along the side. And then if we actually just go here and take this unstacked data structure and call plot on it, we're going to get a nice plot like this. So we could actually see over the weekend, people are writing in the middle of the day a lot more often than during the week. And we see these spikes at about 8 o'clock and 5 o'clock that show people are taking Divi for their commutes. It's kind of all I have right now. Thanks, everyone, for listening to me talk for that amount of time. But I'd love to take questions or chat a little bit more if anyone has anything.